Hello and good day, geometry. Today we'll be starting Unit 3, which is all about angles. And we're going to start talking about angles in the geometric sense with one of my favorite shapes, actually my second favorite shape, if I had to rank them, and that would be triangles. Of course, my first favorite shape is circles, and you'll see why once we get to the circle unit in Unit 10, I believe. But anyway, so triangles. You've seen or heard of most of these words before. Classifying triangles is something that you've done, but just so we're kind of all on the same page here, looking at this from the same angle, one might say, we're going to define them here. And so a scalene triangle is a triangle with no congruent sides. And so an example of a scalene triangle might be something like this. Okay, where you've got a side that's, we'll say 4 and 6 and 9. Okay, none of the sides are congruent. That is a scalene triangle. An isosceles triangle, and check out how that's spelled. There's that hidden C in there. If it ever comes up on a spelling bee or something, make sure you get that C in there. But isosceles triangle is a triangle with two congruent sides and two congruent angles. And the angles that are congruent are called the base angles. In PO26, I believe, we'll learn about the base angles theorem, or the BAT, as the cool kids say. And with those base angles being congruent, the two sides that are congruent are the sides opposite those base angles. If you kind of drew an imaginary segment coming out, and hit those opposite sides, those are the sides that are congruent. So isosceles, two congruent, I'll abbreviate congruent, CON, two congruent sides. Equilateral triangle, triangle where all sides are congruent, and because all sides are congruent, so are all angles. And in fact, in an equilateral triangle, because all angles are congruent, and a triangle can only have a total of 180 degrees in it, we know that each angle is going to be 60 degrees. 60, 60, 60. That's the only way to sum to 180, right? To sum up to 180 with all three being the same. 60, 60, 60. The side lengths, of course, they could vary based on the size of the triangle. They could be 3, 3, and 3 if the triangle's rather small, or they could be 13, 13, and 13 if it's a little bit bigger. But whatever one side is in an equilateral triangle, all sides are the same. So we have 3 congruent sides. An acute triangle is a triangle with 3 acute angles, and we talked about what acute angles are. They're angles that are less than 90. So 3 acute angles. Okay, an equilateral triangle would be an example of an acute triangle. An isosceles triangle also, if all 3 angles are less than 90 degrees, it is an acute triangle. A right triangle, which is my favorite kind of triangle, my second favorite shape, has a right angle, and the other 2 angles are acute. Okay, so that right triangle specifically, a right angle, a 90 degree angle, and the other 2 angles are acute. Okay, and that box there symbolizes that right angle. An obtuse triangle has 1 obtuse angle. Okay, something perhaps like this, right? That angle that is greater than 90 degrees there. That's what makes it an obtuse angle. One year someone asked, well, can a triangle have 2 obtuse angles? Well, no, that wouldn't make any sense. How can you have 2 obtuse angles, right? There's our three sides. If you have 2 angles that are greater than 90 with only 180 degrees to work with, that's not going to make any sense, right? Even if these were both the smallest obtuse angle we can have, 91, 91, we're still above 180. We're at 182. So a triangle can have a maximum of 1 obtuse angle to fit that 180 degree triangle rule that those angles have to add up to. And There you have it, an example. Equiangular is an equilateral triangle, right? All three sides, all three angles, okay? Three congruent angles there. So when we throw out these words for types of triangles, know what they are. I'm confident that for the most part you do, but now you have them down for your notes in a key point as well. Okay? Going to learn some new theorems today, and really you already kind of know at least the triangle sum and the corollary to the triangle sum, but now we're going to officially name them. The triangle sum theorem says that any triangle has angles that sum to 180 degrees. And really, you could replace the word any with every. Every triangle has angles that sum to exactly 180 degrees. There's never been a triangle in existence that it has had more or less than 180 degrees. And why this is helpful, where we're going to kind of get to here is, I think you had one of your con assignments on this too, which by the way, don't forget, con is due tonight. But if we know what two of the angles are, say this that looks obtuse-ish, so we'll call it 100. We'll call this one, I don't know, 50, I suppose. Looks 50-ish. And then the third angle is just labeled angle X. We can solve for that measure knowing that there has to be exactly 180 degrees within this triangle, right? 100 plus 50 plus X equals 180. Because of the triangle sum theorem, and you can't argue with theorems, that has to be true. And so that makes X 30. Okay? So the triangle sum theorem is going to come in handy, particularly when solving equations involving angles within triangles. If you can identify a triangle and you know two of its angles, then you can solve for the third one. The corollary to the triangle sum theorem. The word corollary kind of means like related to or similar to. Okay? And this says, I'll fit a word there, the two acute angles of a right triangle add to be 90 degrees. The two acute angles of a right triangle, because a triangle can only have one right angle, for the same reason they can only have one obtuse angle. A triangle with two right angles, well, 90 and 90 is 180, right? And we only have two of the three angles. So a right triangle, its acute angles have to add to be 90, which logically makes a lot of sense, right? If you know that the total triangle, all three angles, have to add to be 180, and you're given that one of them is a right angle, well, you know, the other one has to sum to be 90. Rather than saying 50 plus 90 plus X equals 180, because you know that right angle is 90, you can just kind of simplify this math and say 50 plus X has to equal 90. Okay? 90 degrees comes from that one angle. The other 90 has to come from the sum of the two acute angles. And so from there, you can get X to be 40. Kind of makes the math a little bit simpler. Very much related to the triangle sum theorem. But when you have a right triangle, you can kind of ignore that right angle, knowing it's 90, and just focus on those two acute angles. All right, so if you need the notes, you can pause the video there, but we're going to move on to an exterior angle. Of course, the word exterior means outside. So an exterior angle is an angle formed by extending the side of a triangle. An exterior angle is an angle formed by extending the side of a triangle. So we're going to draw a triangle here. Okay, and we'll label these angles angle 1, angle 2, angle 3. The exterior angle here, or one of them, there's several that we could form here, but if we take this bottom side and we extend it outward, more to the right, we've created this angle 4, right? This angle that kind of comes down right here. Okay, angle 4 is that exterior angle. It was formed by extending a side of the triangle, and we call that an exterior angle. It's on the outside of the triangle. And with that, the exterior angle theorem, okay, says that, kind of going with this, with the same picture here. I'll try and copy and paste this freehand. Woo. Extend that out. We have 1, angle 2, angle 3, and angle 4 is right here. What the exterior angle theorem says is that angle 1 plus angle 2 is equal to angle 4. Okay. In words, it says that the exterior angle is equal to the sum of the two non-adjacent, meaning not next to, right? Angle 3 is adjacent to angle 4 because they share that side, but the two non-adjacent interior angles. Right? So kind of as an equation in words here, the sum of angles 1 and 2 will equal the measure of the exterior angle. In words, the theorem says that the exterior angle is equal to the sum of the two non-adjacent interior angles. And we're actually we're gonna write a proof for this just to show you, to give practice with proofs and see them more and kind of work with proofs and get more comfortable with them, but also to show you how this makes sense. So I'm going to erase my drawing here on the right. We've got the same one on the left. If you want to jot this proof down, maybe on the back side of this page, just so you have it and you have enough space, great. If you just want to watch it, listen to it, that's fine too. But basically, okay, let's start with what we know, right? Here's our diagram here. I'm using the picture over here on the left. How am I going to make this fit here? I'm going to have to write kind of small, I think. But we've got statements, and we've got reasons. And when looking at this triangle, I don't have a given statement necessarily, but I do know something about that triangle. Okay, I know that angle 1 plus angle 2 plus angle 3 equals 180. Right? And that is because of the triangle sum theorem. What we just learned up above the page. Right? The triangle theorem, the triangle sum theorem says that the three angles of a triangle equal 180. I also know that angle 3 plus angle 4 equals 180. And here's where I'm going to kind of let you, obviously not tell me the answer, but think about it yourself. What theorem, postulate, property, definition have we used before that would tell us why angle 3 and angle 4 add to be 180? Well, if you look at angle 3 and angle 4, what do they make? They make a line, right? And the measure of a line is 180. So because of the linear pair postulate, or the LPP, the linear pair postulate, okay, we know that angle 3 plus and angle 4 have to add to be 180. All right? Now step 3, if angle 1 plus, not angle plus, angle T, that's not such a, if angle 1 plus angle 2 plus angle 3 equals 180, and angle 3 plus angle 4 also equals 180, that tells us that angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4. Tell me why. Or say it and pretend I heard you. Right? Two different things that are equal to the same thing are equal to each other. Remember that we're comparing three things here, okay? The transitive property, because angle 1, 2, and 3 are 180, and because 3 and 4 are 180, then 1, 2, and 3 has to equal 3 and 4 because of the transitive property. I'm going to skip over the diagram here and just continue my proof down below it. I'm almost done here. Because if I'm looking to kind of prove the triangle sum theorem, which I wrote this equation here, angle 1 plus angle 2 equals angle 4, I'm almost there, aren't I? I'm actually one step away. My fourth step, I can take my equation in step 3, and I can write angle 1 plus angle 2 equals angle 4. Because the only thing that I did from step 3 to step 4 was I eliminated angle 3 from both sides. And I can do that because of the subtraction property, right? I subtract angle 3 from both sides. Subtraction property, subtract angle 3 from both sides. I'm left with angle 1 plus angle 2 equals angle 4, which is exactly what we said the exterior angle theorem was. Okay, so this is how math people prove things. You know, math guy, math gal walks into a room of other math guys and gals and said, "Hey, I've got this exterior angle theorem," and they all say, "Prove it, prove it," right? And we did that by using things we all already know and things we can conclude. All right, so there you go. And so PO17 is practiced with both the triangle sum theorem and the exterior angle theorem. You will have a book assignment on this as well as a quiz, just so I can, again, kind of gauge how things are going along. So when you're done with the video, either before or after you do the book assignment, doesn't really matter, log on to Google Classroom, complete the quiz. Completing the quiz is how I'm going to check in your homework for this one. So I guess whether you do the book assignment or not, I'm never going to know. But the quiz is what is going to get you points for this assignment. But here's some examples of what you might see in your book assignment or on the quiz. It says find the value of the variable or variables. Okay, this first one, we only have an x. And recognize, you know, we've got a triangle here with this exterior angle on the outside. And the other two angles that were given are the two non-adjacent interior angles. If we think about our picture from up above, you know, that 70 is angle 1, the x is angle 2, and then that 2x minus 5 is angle 4, right? And so we can set up the equation of the two non-adjacent interior angles, 70 plus x, we know that they have to equal 2x minus 5 because the sum of those two angles has to equal the exterior angle. So now we can use some algebra here. We can move our x term over 70 equal, not 2x anymore. Silliness. 2x minus x is just 1x. Right? 7 equals x minus 5. Add 5 to both sides, and we get 75 equals x. Okay. How we can check this is by, you know, replacing angle x with 75 and plugging 75 in for x and 2x minus 5. That gives us 145, right? 2 times 75 is 150 minus 5 is 145. And does 75 plus 70 equal 145? Yes, it does. So we know that we're right. Right? We've talked before about geometry being kind of like a puzzle. All the pieces have to fit. Okay. If those two angle measures did not equal 145, it's not that the theorem's wrong. Okay. It's that you made a calculation mistake. The next one, we have a right triangle here. And so I think about what I know about right triangles, specifically the corollary to the triangle sum theorem. And I know that these three angles have to add to be 180. So I could write 2x plus x minus 6 plus 90 equals 180, okay? Or, because I already know that right angle is a 90-degree angle, the other two acute angles must be 90. I can set up my equation like that. 2x plus x minus 6 equals 90. The reason why the x minus 6 is in parentheses in the triangle is to kind of show you that x minus 6 is the measure of the angle, right? Not just the -6, or not, it's the whole thing. The way this equation works out, I don't need them. If I did write them in here, that doesn't change what I do, because to get rid of those parentheses, I would have to distribute this +1 that's right there, right? Which isn't going to change anything. So having them, not having them doesn't make a difference. We're going to combine like terms. 2x and x is 3x. Add 6 to both sides. Divide both sides by 3. And we get x equals 32. Checking that, 2 times 32 would make this angle 64, and 32 minus 6 would make this angle 26. Do 64 and 26 add to be 90? Yes, they do. If you remember way back, the first day of geometry, I said that, not only is geometry this brand new language thing, right? But if you can add and subtract to 90, 180, or 360, then you're going to do great, right? And we saw the 180 with the straight lines before. We see 180 again now with triangles. We saw the 180 with supplementary angles. We saw the 90 with complementary angles. We see 90 with right triangles here. We'll see 360 with both quadrilaterals and circles. Okay, but yeah, those are kind of your 3 big numbers for geometry. This last one, actually, every year I tell myself to take this out, and every year I forget. I'll probably tell next year's group the same exact thing, but we actually have not learned about how parallel lines affect angles yet. That's coming up in our next objectives. So you can skip this one. We're not going to solve it now. Well, we'll tackle it when we get to, I think, 19. 20 maybe. But just so you know, if you do see those 2 triangles on lines, it means the lines are parallel. There are actually a lot of really cool angle relationships that exist when you've got parallel lines within a figure. But we'll save that for another day. So your homework is going to be your book assignment on page 221. I would like you to do 1 through 6, 14 through 19, and 21 through 26. 21 through 26. There's also a Google quiz posted in Google Classroom along with where you found this video that I'd like you to take. I will be posting another video for you to watch on Friday. I'll give you until the end of the weekend for both of these assignments. You'll have a quiz for that one too, for PO18. So PO17 and PO18 quizzes are due by the end of the weekend, so I can kind of gauge where we're at heading into next week. All right, that is PO17 featuring the triangle sum theorem and the exterior angle theorem. I hope you folks have a great day. That is How You Math. Do not forget to like and subscribe.